Welcome back to the shop and to the channel. In the last video, I got the arbor machined for this drive gear, and now I need to do a little work on the gear itself. It's a bit too thick for what the dimensions would call for. I picked up this 0 to 1 micrometer. It's a Chinese import from an auction for $5, and I must say, it actually feels pretty good in the hands. But anyway, I'm going to use it here to measure the thickness of this gear, and it's a bit over 1 inch, and that's too much. So I need to get this down to about 900 thousandths. And I think the easiest way to remove that thickness is just to take it over to the lathe, and we'll chuck it up, and we'll take off a little more than 100 thousandths on this. I'm going to use a couple of parallels here on the lathe chuck. I'm just going to use my 3-jaw to space this out from the chuck so I have some room to machine it. I'm not worried too much about concentricity, although I think this will be close enough for what I need to do. I do want to be sure to maintain some parallelism on the width of the gear, so I'm just going to use a test indicator on the face of the gear, and I'll turn the chuck by hand and just to see how far out this thing might be. Should be pretty close. So it looks like I might be maybe 5 thousandths out of flatness. I don't know what you would call this particular dimension, but in either case, I do want to tap this in and get it closer. 5 thousandths isn't bad, but I think we can do better. I'm going to tighten the chuck down a little bit. I know it's going to move some, but it shouldn't move too much. And it looks like I'm within maybe 1 thousandths, and I think that's fine. I think that's more than acceptable for what we're doing here. Well, I've got a tool in the tool post here. It's a CCMT insert, and we'll touch off. And I'm going to use this magnetic base indicator. I put this on the ways and attach it so it touches the saddle. And this will let me see just how much I'm moving the saddle, since I have no other way to know. There's no DRO on this machine, and this will let me know when I need to stop. I need to take about 112 thousandths off of the thickness. Well, I'm not sure what material this gear is made from. I asked Cooper, he didn't know either. It was just a piece of scrap that he had, and it's just giving me a bit of chatter. I know it's a hard material of some kind, because it is giving me a little bit of blue in the chips, a little bit more blue than I would have expected. But I'm going to wait and finish this cut and see what the surface finish looks like first. Well, that's some pretty good surface finish, even though there seemed to be some chatter during the cut. Maybe it's because of the way this is being gripped, but I'm pretty happy with the surface finish. I do want to check to make sure that I am, at least cutting parallel here. So I'll use this anvil micrometer to check the thickness in a few different spots, just to see how much we just took off, and just to make sure that I do have this thing in here relatively flat. Well, all that looks good. I am going to change the tool out here for a DCMT insert and see if this does any better than that CCMT insert did. I'm going to have to reset the 0 on my dial, but I am a bit concerned that I'm going to have trouble even taking this a little bit off. We'll see. Let's see how this goes. Yeah, I'm not liking that at all. This is definitely not the right tool for facing on this particular material. So I think what I am going to do is I'm going to switch back to the CCMT insert, but I'm going to swap the insert out for one with a different coating. Alright, this insert has a coating on it that's supposed to be for harder materials. So we'll see how this goes. I do like this CCMT geometry. It really is a good all-around insert. I do wish, honestly, these were CNMGs because I'd get more corners out of it. As it stands, I only have 2 usable corners in this tool holder. It'd be nice to be able to flip it over and get 4. But let's see how this does this time around. Well, it's not breaking a chip at this depth of cut. These spaghetti chips, I really hate them because they can really do horrible things to the finish, and they're a bit dangerous, especially if they get wrapped around whatever part you are trying to make. But I'm not getting any chatter, and the finish, at least for now, as much as I can see it, actually looks pretty good. Yeah, I do like the surface finish. It's really looks good. It might be hard to see this on the camera, but I'm really happy with it. So I think we're going to stick with this particular insert and um, maybe adjust the feeds depth of cut. See if I can't get a better chip. Well, a little deeper depth of cut, it's at least curling a little better. It's not making spaghetti, and here that curl has sucked its way down into the spindle, which is fine. At least it won't be getting wrapped around my hands. This is a better chip. It's not a perfect chip, but I think this particular insert wants, a nice heavier cut in order to break a decent chip. Well, my target is about 26 thousandths away, so I've got just a little bit more to take off of this. Everything is looking good so far. I do like the surface finish, um, and taking that heavier cut, I am getting at least a better chip, and not that rat's nest of spaghetti chips. I'm going to go ahead and dial in all 26 thousandths at once. This does not need to be super precise. I am machining this a little bit thicker than what I think the book would call for. I think it wants to be 7/8, 875. But I can always machine off a little bit more. It's a little bit harder to put material back. So I'm kind of erring on the side of caution. Once I get this mounted up in the mill, it'll give me, a better idea of how it's fitting. I plan on, doing some testing and measuring, and if I need to take the gear off and machine a little bit more, or maybe even add a spacer, I can do that. I'm trying to do this to where anything I do won't trash the part, because getting a new gear or getting a new arbor would be very difficult, if not impossible, or expensive. Well, it looks like I overshot a little bit. I'm a thousandths under, so I'm at 899, and that's fine. I think that's great. So now what I want to do is match the chamfer that was on it before. So I'll swap out this tool for a chamfering tool and put a little chamfer on those gear teeth. Well, I did put a little chamfer on the inner bore again, but I bumped the camera while I was doing that, so that scene got cut from the final film. So I can pop this out of the chuck, and let's go over to the bench and see what I need to do next. Well, the machining on the gear is almost done. There's still some more I have to do with it, but that'll come later. I did go over to the horizontal mill and remount the arbor and my lathe tool post. I did take a little bit off of the face of this arbor. It was still a little bit proud, and I wanted it to be about 2 thousandths, 3 thousandths shallower than the gear width. And that'll make what I need to do next a little bit easier and better. It'll make everything fit a little bit better. Well, the next thing I need to do is make a spacer that goes on the front of this gear. And you can see from this diagram that there is a spacer. It gets bolted to the front of the gear, and it needs to be the same diameter as the diametral pitch of the gear, which in this case is 3 inches. Now you'll see also from this diagram that there is another spacer that is bolted and pinned to the back of the driven gear, which is inside the universal head itself. Now when the head is installed and these two gears are meshing together, these two spacers are actually touching, and what that does is it ensures that the gears are meshed properly, not too tight and not too loose. So the size of it is pretty important. Well, I think this piece of 1/4 inch plate, no idea where I got it from. I think it'll be a suitable piece of material to start from to make the spacer. It needs to be about 1/4 of an inch thick. I think it can be a little bit thicker or a little bit thinner. I'm actually shooting for around 225 thousandths. Well, somebody sent me a plasma cutter, and I thought about using it to cut this material out, but I kind of feel like that's a bit overkill. I haven't even plugged the thing in to try it yet. I think that's going to be a different video. I think for now I'm just going to figure out how much material I need to cut off of this, and I'm just going to use the bandsaw. Well, now that I have a piece that's kind of square, I'm going to use the fly cutter here to clean up the top and bottom surfaces. Well, with the top and bottom surfaces nice and finished, I'm going to use the edge finder here and the Bridgeport to find the center of this piece. It doesn't need to be perfect, but I need to start drilling some holes. I'm going to drill 5 countersunk holes that I'm going to use to mount this plate to both the arbor and to the gear itself. I probably don't need 4. I could probably get away with 2, maybe even 3, but you know, nothing ever broke because it was too strong. Well, I'm using the spotting drill here and, of course, a little bit of anchor lube. I thought about just spotting it and then switching out to another drill, but this is a 1/4-inch spotting drill and I need 1/4-inch holes. So I figure I'll just use this drill. I don't think there's anything wrong with doing that. This plate's pretty thin. There's not much in the way of flutes on this spotting drill. I don't know, is this a bad idea? Put something down in the comments as to why I should not have done this. Well, I have 4 more holes to drill in this plate, and they're going to be 7/8 of an inch from the center. Well, I've got a nice big heavy countersink bit in the chuck, and I've slowed everything down. Got the Bridgeport in back gear. I want to get this thing deep enough so that this countersunk cap screw fits down in there flush and a little bit more. I don't want it to be proud of the surface of this plate at all. Well, I've got the quill stop set so that all of these countersinks will end up to roughly the exact same depth. Well, I think it was much easier to drill these 5 holes now than it would have been if I would have turned this into a circle first. Of course, it does leave a bit of a nasty burr on the back of these. I've got this handheld deburring tool that comes in handy for deburring the backs of holes like this. These are a little bit tough. I don't know what this material is made from, but these burrs are pretty tough. Maybe it was because I used that spotting drill. Maybe that left too much of a burr. I don't know. But I think what I am going to do is put a countersink back in my drill press and clean these up a little bit better off camera. And then we'll take this back over to the lathe. Well, I need to turn that square spacer into a round spacer, and using the lathe seems like the appropriate tool. I've got a piece of scrap here I'm going to chuck up in the 3-jaw, and the point of this is I'm going to drill and tap a 1/4-28 hole in the center of it so I can mount that square plate in it to do the final machining on it. I figured using a larger piece of material to mount it to will help me with some rigidity. That way I don't have any issues turning that really thin spacer. Of course, the first thing I need to do is face this off so it's nice and flat. Well, to get this fixture ready for that spacer plate, I need to drill and tap a quarter 28 hole in the center of it. We'll start with a centering drill and a little bit of anchor lube on the tip, but just the tip. Next is the tap drill size for quarter 28. I think this is a number 3 drill, if I remember correctly. Put the lathe here in back gear, and we'll go ahead and power tap this. Well, I should have put a countersink on this before I tapped it, but never too late. I'll put a countersink on it and then run that tap through again, just to clean up the beginnings of the threads. Well, I'll clean up the face of this fixture, and we'll go ahead and see how the plate fits on here. If it is nice and snug, as I suspect it will be. Well, that does fit on there nice and tight, but I'm not going to machine off all of these corners on the lathe. But what I do want to do is sort of establish what my circumference or my maximum diameter would be. So I'm going to come in here with the lathe tool and get it close to the edge of the flattest part. And I'm just going to touch it. Just put a little bit of a line on the face of this plate. I'll take it over to the bench and just cut those corners off with an angle grinder and a zip wheel. I'll do that off camera, and then we'll come back and remount it to the fixture. Well, I got the corners nipped off over on the bench, and we got this remounted. So now we'll take the machine out of back gear and start machining it down until we get a cleaned up circle. Well, there's one spot there that's about a quarter of an inch long that didn't clean up, but that's okay. We still have probably 150 thousandths to take off. We'll measure this real quick with the calipers, and I don't remember what the exact measurements are, but it's about 150 thousandths to go. Well, we hit our target. We're right at 3 inches, maybe a half of a thousandths under, depending on how you hold these calipers. But plus or minus a thousandths or two won't make a big difference here. So we'll go ahead and take out this tool and put a chamfer tool, and we'll chamfer both sides of the plate. Well, I can't get to the back side of the spacer because the fixture is too close to the chuck jaws. So I'm just going to take it off, and I'll turn it around and mount it the opposite way and chamfer it that way. Well, that should be it for the machining on the spacer. We'll take it back over the bench and get a closer look at it. I'll do a little dry fit, as it were. Put the spacer on here and mount it into the arbor. See how it fits. It looks pretty good from this perspective anyway. Well, I still have to drill the 4 holes in the face of the gear for the other 4 mounting screws and machine the drive dogs on the back. But that's going to have to be for another video. If you like the video, give it a thumbs up. Subscribe if you're not a subscriber. Thanks for watching, and we'll see you on the next one.